Good evening, everyone. Sorry for delay. Yeah, so if audio, video, everything is okay, so we can start the class. Let me know audio, video okay or not. Check everyone. Is audio, video okay or not? Verify. Little doubt also there. Let me know. Yes, I think it's now perfect. Audio, video also okay. We can move to the actual story. Right? We can start. We can start now. So I'm starting. I'm starting now. Right. Thanks everyone. Thanks everyone for attending. So I'm starting. Yeah, this is the thing. So I think today's date, if you observe, I think it's 1/12/25. This is the today's date. 1/12/25. Right. So today's topic, if you see, 15 basic problems of linked list. So if you see all these 15 problems, most probably you will be perfect, right, with the linked list and all. Most probably you will be perfect. So I'm starting 1/12/25. Today's class, first problem on the linked list, first problem. To be frank, on the linked list, first problem. Right? So ready? I'm starting 1, 2, 3. Yeah, go ahead. Can you see this problem? Write a program to create a single linked list with 4 nodes and print their values. Many people, I think, most probably can easily do this. If you know the linked list basics, you can easily do it. Write a program to create a single linked list with 4 nodes and print their values. You have to create and you have to print also. It's a very basic problem. Everyone can do it. It's a very basic problem. Everyone can do it. It's a very basic problem. Everyone can do it. Not only you and me, everyone. Right? It's a basics. That is the reason it is called basic problem. 15 basic problems of linked list. In last week we done, right, 15 basic problems of, right, arrays we done. Arrays are list. 15 basic problem of arrays are list we done. Now in this week we are going to see 15 basic problems of linked list. It is the first problem. Write a program to create a single linked list with 4 nodes and print their value. Right? You may say that's how to create. Right? Linked list is a very well dynamic data structure. So I think using some dynamic keywords, right, most probably you can handle. In the C language, I think there is a malloc function, calloc function. In the case of C++, there is a new function, new keyword. Right? Using the new, you can create the memory. Right? In the Java also, I think same. Right? In the C++ and Java similar. In Python, I think using constructors you can do it. Using object oriented right, programming. So right, OOPS concept, using OOPS concept constructor, you can do it. So most probably in every language, directly same. C also, Java also, Python also, using constructor you can do it. Using OOPS, right, OOPS concept we can do. So I given the some small idea also. Can you see this? So what is the way? So if the input is, right, see this one, if the input is 10, 20, 30, 40, right, so these are the values for the nodes. You have to show finally, right, expected output will be in the form of linked list like this. We have to show how. See this one, define a node class with 2 properties, data and next. Create 4 nodes with different values. So that these are the first 2 steps. You have to create 4 nodes with different values. How? So I think you can see this. So this is the, right, one class we created in Python, right? OOPS concept, almost similar like C++, Java, right? Just to go through the basics of OOPS concept in the, right, Python language. So this is the class node. right? So right, self dot data is equal to data, self dot next is equal to next, next is equal to none. So first time, see this one, first time class is called node 10, one node is created. Second time node 20, one more node is created. So first time when you created a node, node 1 will be there. So like this, node 1 will be created with the two parts, 10, and I think second one is a none. It is created like this because of first one. It called, right, class. Using this class, one node will be created. Assume that it is returning address 1000. That is pointed by node 1. This is called node 1. This is called node 1. When I say node 1, when I say node 1 dot data, it is something like structure, right? But here it is called as class. Node 1 dot data 10 will come. Node 1 dot next, node 1 dot next, none will come. This is called data. This is called next. Similar way, next second time node 20 is called, right? Using the structure or using the class or using the constructor, indirect way of saying. So you can create one more node that may be 2000. That is called dynamic memory allocation. This is data. This is next. This is going to be 20. This is going to be none, like that. So this is node 2. This is node 2. When I say node 2, see this one, when there is no pointers here. Remember everyone, there is no pointers here. When I say node 1, I am inside. Dot data 10 will be printed. Dot next, none will be printed. Similar way, node 2 inside. Because it is a class, it is a class. Node 2, you are inside. Dot data 20. Dot next, null. So like that, 4 will be created. 4 times you called. Every time, not only creating, that will be returned to node 3. So that is pointed by node 3. So it is going to be 3000. Node 3. It is also created. Node 4. Its data is 30 none. Data is 40 none. Right, something like that. Data next. Data next. Like that it is created for people. Now observe here, after creating, link them. Until now nodes only created. Link them. How? Node 1 dot next means this one is equal to node 2. Node 2 means this one. Right? Remember everyone, node 2 means 2000. Right? Node 2 means 2000. Node 2 dot data, so 20. Node 2 dot next, so null. Right? Like that. So this will be linked like this. It is 2000. It is 3000. It is 4000. Like that, linking is done. Right? Fine. So if anyone is confused because of me, so see this one. When I called the node 10, right? One node is created with the data 10 next as none, right? It will return the address also that will store in the node 1. Node 1 is address. If anyone is confused because of me, I am rectifying again. I am reiterating again. When you call node 10, one node is created with the data is 10 next as right, none. Not only creating, it will return the address that will store in the node 1. Node 1 is 1000. Node 2 is 2000. Node 3 is 3000. Node 4 is 4000. So like that, all will be created. Okay, fine. 4 are created. Now linking is going on. Node 1 dot next is node 2 means 2000. Node 2 dot next is, right, node 3, which is going to be 3000. Like that, all linking is done. After linking is done, right, after linking is done, lastly, can you see this one? I think last person, if you see until now here written, I think sorry for this, I think this is this one. I think if you observe clearly, node 3 dot next is equal to node 4, that is also done. Last one, you no need to change anything because the last one anyhow none is there. Last one next is anyhow none, so there is no requirement. Right? Next one, head is equal to node 1. This is head also. Not only node 1, it is a head also. So till now, if you observe clearly, linked list is created. 4 nodes linked list is created using object-oriented concepts, or using class concept, or using constructor, right? 4 nodes linked list is created pointed by head. Remember, head means 1000. Head next means 2000. Head next means 3000, something like that, you know very well. So I think this also completed, this also completed, this also completed, right? I think let's go to main program. This is the main program. See this one? This is the main program. Print created linked list is. Print created linked list is. So one thing will be printed, okay? Afterwards, linked list head called. Linked list head. Head means 1000 is called. 1000 is called. It will go there. It is 1000. Now go here. Current is equal to head. Okay. Now current is not none. Until not none, continue the story. What that one? Print the data, then arrow symbol. Again, current is equal to current next. Again, 20 arrow symbol. Current is equal to current next. 30 arrow symbol. Right? Next one. 40 arrow symbol. But when you call the next one, none is there. So none will be printed. Lastly, none. See this one. Lastly, none. Lastly, none. See this one. While current is not none. No, none. None. You will come outside, print none. None also printed lastly. None also printed lastly. So the only basics which you need for this particular one is just learn, right? In the Python language, just learn, right? Oops concept. Oops concept, please learn. Just do few problems practice, right? Oops problems, right? Oops concept, please learn little bit. Then automatically this is very easy. So now the question is going to be, what is the time complexity? Because of only 4 nodes, 4 nodes creating, 4 nodes creating, 4 nodes traversing, which will take constant time. So time complexity, space complexity, if you observe, right? Constant. Time complexity also constant, space complexity also constant. Just know the basics. Just know the basics. I think I done the right Python program. Same thing with the C++ also. In the everything similar in the C++. You may see new function, new node, new keyword you will use. For a dynamic memory allocation, new keyword you will use. Other than that, everything. This is linking. This is creating. Right? And one more thing, because of right C++ language also uses, right? Uses, right? Constructor, right? So, and class, this is the class. This is the class and constructor, same. C++ also uses same story. Afterwards, traverse the list and print it. Using one while loop, traverse the list and print it. Same story. That is the reason when you learn the data structure algorithm properly, right? Most probably all the languages you are comfortable. Just syntax will be different. Syntax in, I think in Java language also new function. Same story. In the Java language also linking. Little bit differences are there. Next one, I think traversing, one while loop is required. I hope everyone is comfortable. Right? Question number 1, we done. One of the basic problem is creating linked list of four nodes linked list and traversing. Question number 1, everyone is comfortable. Let me know anyone having any doubt. Someone is saying, is this live class? Of course, it is a live only. Manoj, it is live only. Manoj, it is a live only. Thank you so much. Thank you. Yeah, because I'm keep on teaching. That is the reason I am not able to see the chat. I am not able to see the chat because in the middle I cannot see. After completion of right, one problem at least I have to see. After completion of at least one problem I have to see. In the middle, if I keep on see, I may not able to finish it off. Thank you so much. Thank you, Manoj, for asking. Thank you, Pankaj. Yeah, let's go to next problem. Problem number 1, I done. Let's go to problem number 2. Write a program to count the number of nodes in a single linked list. Can you see this? Write a program to count the number of nodes in a single linked list. Right? See this one. I think if you see the linked list, 4 nodes are there. You have to return the 4 as the answer. Right? What is the answer? First, initially counter is 0. These are basic problem. Try to understand. These are the basic problems. Try to understand. Initialize a counter variable. Okay. Next one, start at the head node. Okay. One linked list is given and counter variable initially 0. Linked list is starting with the head node. Just it's the algorithm, right? Next one, while current node is not, means until none continue. Every time counter value will increment by 1. Whenever you see the none, stop it. Lastly, return the counter value, right? I think same thing you can see one time here. Create a linked list first. Create a linked list first. This is not our purpose. Our purpose is only counting. For your convenience, I created. Using structures, right, or using oops concept, or using the class concept, create a linked list of 4 nodes. Yes, I created. Yes, I created a linked list like this. 4 nodes or 5 nodes or n nodes I created. Right, some address is there, 1000, 2000, 3000, 4000, like that you created. It's a none. So 1 here, 2 here, 3 here, 4 here, like that all are there. This is pointed by, I think, head. Okay, until now fine. Until now fine. Now let's go to main program. This is the main program. This is the main program. Right, this is the main program. Let's see once. Total nodes in the linked list is, count function is called by passing head. Count function is called by passing head, right? Head is going to be 1000. 1000 is going. 1000 is going, right? So go to the count function, right? By passing 1000. Okay, fine. Initially count is 0. Current is equal to head. While current, right? So remember, until here none will come. Until here none will come. Continue. While current means current is not none. Then current, right? Count is equal to count plus 1. Current is equal to current next. Like that, continue until none will come. So it is initially current. So is it none? No. So count is equal to count plus 1. Count is 0. Make it 1. Count is initially 0. Right? As soon as you went to count, inside 0 is there. See, count is initially 0. It's a current. See, you assume. Count is equal to initially 0. Current is a first node. Current, right? While current is not none. Yes, true. Count is equal to count plus 1. Right? It will be 1. Current is equal to current next here. Is it not none? Yes. Again 2. It will increment. Is it not none? Yes. Increment. It will also go here. Is it not none? Yes. This is 4. Current is equal to current next. I think it is now none. Current, right? Now, while none, condition is fail. While none, condition is fail. Right? While none, condition is fail, you will out and return the count. 4 will be written. So finally 4 will be printed. I hope this also everyone. I think one scan you are doing. Remember, these are the basic problems. Remember everyone, these are basic problems. These problems are basic problem. Try to understand. One scan you done. And one more thing, if you observe, you are not right. If the linked list is given, if linked list is given, you are not creating any node. If linked list is not given, you are creating also. Right? It depending upon given or not. If linked list is given, you are not creating. If linked list is not given, I created. Right? See this one. Right? Because in the problem is mentioned. Can you see the problem one time? See the problem one time. Write a program to count the number of nodes in a given single linked list. Linked list is given. So time complexity n, space complexity 1. Right? Creation, no need to bother that much. Space complexity 1, because linked list is already given. Time complexity 1, scan, order of n time. So 2 problems I done. One is creation. Linked list creation is 1. That is a 1 problem. And one more. Counting total nodes. That is a 1 more problem we done in today's class. Right? Let's see some more problems. Let's see some more problems. Sir, you can see YouTube chat. Yes, of course, I seen. Right. Maybe I given little late, but I seen your chart. Thanks for informing. Thank you so much. Let's see the another one. Let's see the another problem. 2 problems I done in today's class. I done 2 problems. Right. This is today's class. I done 2 problems. Let's check. It's I think 2 problems I done. Can you see the third problem? Can you see the third problem? Everyone, can you see the third problem? Linked list, third problem. Linked list, third problem. Everyone observe the third problem. Write a program to display single linked list in the reverse order using recursion. You have to return the single linked, you have to printing or displaying. You have to display the single linked list in the reverse order using recursion. right? When he says simply reverse, you can do whatever way you want. But he is asking using recursion. You have to use the recursion. So I think creation of the linked list, don't think that much. Until here creation. Until here creation. Until this part creation. Just wait, I think yeah, charging needed. Just wait 1 minute. 1 minute wait, some charging problem is coming. Just 1 minute. Yeah, it's fine. So this problem we have to take care. Can you see this? Can you see this one? So create a linked list. Create a linked list. Okay, that is not part of this, but using recursion you have to do. You have to do this one using recursion, right? You have to do this one using recursion. So if you observe clearly, there is a recursive program. There is a recursive program. So I will show the code to you, right? Print reverse from main program. From main program, see, head is equal to create sample list. Okay, created. Afterwards, print the list in the reverse order. Now call the recursive function. Now call the recursive function. When you call the recursive function, this is the code of the recursive function. Can you see this? This is the code of the recursive function. See now, it is the code of the recursive function. So as soon as you go inside, ask is head is none? No. If none, simply return. If not none, call the recursion. First one will call second one will call third one will call fourth one, and so on. Whenever none, from there onwards you are returning. While returning, you are printing it. See, while returning, you are printing. When you are returning, you are printing it. Are you understanding here? Here. When you are returning, so while going, you are not printing. While coming back, you are printing. While coming back, you are printing. While going, you are not printing. 1 will call 2, 2 will call 3, 3 will call 4, and so on. 1 will call 2, 2 will call 3, 3 will call 4, and so on. Whenever you see the none, from there onwards in the back side, start printing. From there onwards in the back side, start printing. In the back side, start printing. While going, you are not printing. While coming back, you are printing. How can you say while coming back? Whenever you see none, then print. Whenever you see the none, then print it. While going, you are not printing. See, if you see the recursion there at the printing there at the last place. Can you see there? Printing is there at the last place. What is the meaning? After seeing a none, you are printing. Go next, using recursion. Go next. But everywhere, do you identify or not? Printing is pending. So when the pending thing will be done, while coming back, it will print. While coming back, it will print. Let me know if anyone having any objection. In the given linked list, in the given single linked list, remember it is a single linked list. In the given single linked list, whatever nodes are there, you have to print in the reverse order. While coming back, print. Right? While coming back, print. Observe clearly. While coming back, print. While going, don't print. While coming back. So you may say that, sir, how much space, how much time? Because if you have to go from starting to ending, end time. While coming back, you are printing. So one more n. Going purpose n, coming purpose one more n. Totally n plus n, 2n. Time complexity n. What about space, sir? Because if it is a recursion, you are using stack. If stack is not there, where it will store? You are coming back means where it will store. So you are going okay, while coming back you are printing. Then where is the data? Means how can you print while coming back? Where data is stored? Data is stored in the stack. You are using stack data structure, right? So first in last out, or last in first out. Last one you are printing first. Then you will go to previous. How will you go to previous? Everything there in the stack. I can go to previous. So time complexity n, space complexity n, right? You can do whatever language you want, simply using recursion. Every language supports recursion. Simply using recursion. Simply using recursion, you are doing it, right? So I think if you see, right, that is the last statement is print. Similar way in the other languages also. Similarly in other languages also, if you observe clearly here also, can you see this one here also? Print reverse. See, printing is last. Printing last. In every language, printing last. Syntax will differ. That is the reason I can say confidently. Right? I know all languages confidently. Just maybe if it is a completely new language, if I don't know anything, it may take some time. 1 week maybe I will take to learn that language. I can say confidently I know every language. Confidently I know, because logic is same, right? So in some language while loop will be written, some, right, syntax will differ. In some other language recursion, some syntax will differ. Function calling syntax will differ. But fundamental things, 90% all the things are similar. So right, printing the single linked list in the reverse order. Calling. Whenever none will come, from there onwards, keep on printing. So it's a Java program. Java also same story. Create a linked list, right? It's a create a linked list. This entire story is creating a linked list. Okay. Then afterwards, call the reverse. Reverse function is called. Go there. Right? When you see the reverse function, null, simply return. If not null, call. See, every time you are keep on calling. Lastly, when you see the null, from there onwards, print. In the reverse order, you are printing. See this one? This is system.out.print. System.out.print. In Java language, you will print like that. In Python language, simply print. In C++ language, maybe cout. Just way of writing is different, but all fundamentally will do similar story. Can you go to problem number 4? Today I done until now 3 problems. Problem number 4. Write a program. You may say that, sir, these are small. That is the reason these are basic problems. Sir, these are very small. Now, how can you say this? That is the reason basic problems. You be comfortable with the basic problem. Automatically, right, remaining things will become so easy. First, comfortable with the basic problem. Remaining things will become so easy. Write a program to display a single linked list in the reverse order using recursion. I think we done reverse order using recursion. I think what is the third problem we done? I think third problem also same, or what? Any mistake happened? Write a program to display a single linked list in the reverse order using recursion. Let's see the fourth problem. Display single linked list in reverse order using recursion. I think same. I think small mistake has happened. So yeah, let's move to next problem. Write a program to convert an array or list to using a single linked list. Converting an array or list to into single linked list means I have a list to, or I have a array. In the C language, it is C and C++, Java, it is called array. In Python, it is called list to. I have a list to, I have to convert into single linked list. How? Right? So I think like this input, you have to convert into linked list like this. How? I think same story now. In the array, first person you take, right? In the array, first person you take, call him using a constructor, create a node first. Current is equal to head. Now using the for loop, right? Every time call the node, one node will be created, that will be stored in the node next. You will keep on create, link to the next one, keep on create, link to the next one, create like that until list is over. This is the way how to access the list, right? Array of one column, indication that all the things will come, all the things one by one onwards they will come until null, one onwards it will come until last, all will come. Every time I will call the node, I will create a node, I will keep on link to the next one. After creating all are over, come back, then print it. So this is the first initially, right? So array to list you called, it will finally return head. Then afterwards linked list from the array, right? So print linked list, you can print the linked list. This is the one using one while loop is printing. I hope everyone got it. Let me know anyone having any objection. Let me know if anyone having any small objection also. So in today's class, we done the 5 problems. In tomorrow's class, we will see one more 5 problems. In tomorrow's class, we will see one more 5 problems. Right? 5 problems we done. And notes also I can give to you. Notes also I can give. Right? If anyone say, sir, notes required, I will provide notes. Yeah. If anyone say notes also I will provide. Let me know anyone having any issues. Ready, sir, I need this help, that help. Let me know, I will help you. And one more thing is algo, right? So careful everyone. One more thing is DSA, right? DSA course. If anyone want to be comfortable, in the DSA course is going on, right? EPT DSA course you join within 3 months. Within 3 months, all the things, all the basics you can learn. Then you can practice all these problems. Right? 3 months, learn all the basics. First lecture, so first one you are going to discuss time complexity finding. Next one is asymptotic notation. Next one is, right, next one is recursion. Right, next one is recurrence relation. Next one is divide and conquer. Next greedy. Next dynamic programming. Next, right, all the graph algorithms like BFS, DFS. Right, next one arrays you can learn. Right, next one it is going to be binary trees. Right, next one is going to be binary search trees, ABL trees. All the trees you are going to study, followed by stack, followed by queue. All the things you will study. Right, 80% discount going on, you can utilize. 80% discount going on, you can utilize. Within 3 months you will become expert in the DSA, followed by all these practice problems. Right, it will make you are so strong in the DSA. 80% discount going on, you can utilize. Let me know if anyone having any small issue. Right, I'm going to help you. Sir, I have this doubt, I have that doubt. If you have anything, you can ask, I will help you. Let me know any issue. Today I done 5 problems, tomorrow mostly I will do one more 5. So like that, 15 problems we are going to cover. All the basic problems we are going to cover. Right, fine. Thank you so much. See you in the next class. If you're really serious about DSA, you can join the EPT DSA course. It is a 3 months course. Within 3 months, it will be over. Right? So you will do the approximately 500 problems we will practice. Approximately 500 problems we will practice. Right? These are right EPT classes followed by these 500 problem. You will be perfect in the DSA. You are going to be perfect in the DSA course. Trust me, you will be so good in the DSA course. Right, in the last week, 50 problem of DSA we done. Right, for the, I think I can say, for the arrays we done. Now in today's class we done the 5 problems of linked list. I think we will take a few more problems. Linked list also will cover. Like that we will keep on practice one by one and so on. Thanks everyone. See you in the next class. 80% discount going on. I hope you will utilize it. You want to be so good in DSA, right? You can join the DSA classes. Thank you. Thanks everyone. Thank you so much. Thank you.